let us look at some of the example that is which is not the standard single function. Okay, so let us look at E7. Okay, so E7 sine inverse x is a single function, but it's a combined with our x. So actually it's a product of the two different functions. The first one is x, the second one is a sine inverse x. So if you still remember, that is, you only have learned few three methods. One is chain rules, one is product rule, and one is quotient rule. So this one is applicable to the quotient, the product rules. Okay, so let my x is become the u, my sine inverse as an v. So my u is an x, so u prime is 1. Then I have my v is a sine inverse x. So follow exactly this one. So my v prime. Okay, so w actually is my x. So I need dw dx actually equals to 1. So I copy back exactly 1 over sud 1 minus w actually is x squared. Dw dx equals to 1, so multiple 1. And then applicable to the formula uv prime plus vu prime. So u is x, v prime is this one, so over sub 1 minus x squared plus v is a sine inverse x, and then u prime equals to 1. So we finish our differentiation for this combination of two different functions. Okay, so if you look at the E7 and E8, they have a little bit similar, but the thing is the difference will be your sine inverse x is the one come with a power of 2. No need to think much. The only thing, this one is your u, and this one is become your v. U equals to x, so u prime equals to 1. When I have a v equals to sine inverse x, take everything square. So you just differentiate according to like the power rules. So v prime, push the 2 in front. So sine inverse x, 2 minus 1. Differentiate sine inverse, we already differentiate here. So it's become 1 over sud 1 minus x squared. So follow the formula. uv prime, so is x. Okay, so it's 2x sine inverse x over square root 1 minus x squared. Then plus with the vu prime, so is the sine inverse x square multiplied with 1. Okay, and please don't go to bring the 2 in front. Okay, please don't write as this one. Maybe some books written, please don't do so. Just keep and power is outside. Okay, so then we look at the E9 and E10. Okay, E9, you have three different functions. The first one is sine inverse. The second one is x. The third one is a square root. Okay, but sine inverse over x, okay, this one is the one in the quotient. Okay, but for the third 1 minus x squared, related to the first term is by the operator of plus, so that means the third is standalone, so we only need to do the quotient for the sine inverse. Okay, remember uv actually differentiate. Uv is v square, vu prime minus uv prime, so let our u equals to sine inverse x. So the u prime is just now we already did 1 minus x squared. Then our v equals to x, so v prime equals to 1. So the formula are vu prime minus uv prime over v squared. So v squared is x squared. V here, v is x. U prime is 1 over sud 1 minus x squared. Then minus uv prime, so is a sine inverse x multiplied with 1. And if you see here, this is one layer, this is the second layer, this is the third layer, which is not allowed. So we try to simplify the first term. So I'm going to have my x over, okay, we have the similar equate this denominator, so 1 minus x squared. So the second term is going to multiply with 1 minus x square sine inverse x. If you notice that is I seldom put the square root at the back of a sine inverse because later on I worried that is soon or later you make it look like this one. Okay, so which is this is not correct because this one is belongs outside of our sine inverse. Okay, so and then we have our overall x squared. So now if you rewrite, so it become x minus square root 1 minus x square sine inverse x over x square root 1 minus x squared. This one is only for the differentiation of sine inverse x over x. So how about the second one? So it's going to plus, okay, so this is for the first term. So plus the differentiation of 1 minus x square. Third, we change it to the power of half. So differentiate using power rules. So half 1 minus x squared. Half minus 1 is negative half. Differentiate inside the using the chain. So it's minus 2x. So simplify. So this one is become x. If you want to bring down the power also can. So it becomes square root 1 minus x squared. Okay, so and then you combine these two. So it's your final answer. Okay, so let us look at our E10. Okay, our E10 is a little bit special. If you notice that is the 2, the power of 2 actually is for the tangent inverse. Okay, if you notice that is, although last time we used to write sine x power of 2 as in sine squared x, but the thing is in over here we hardly want to write this as a minus 2. Okay, because it will be confusing because we already declared that is the minus 1 here representing inverse. Okay, we cannot say that is tangent minus 2. Okay, is it this one is 1 over tangent x power of 2, or this is a tangent inverse x power of 2. So to avoid this type of a confusion is we hardly want to write as minus 2. Okay, so now this one is the whole thing power of 2, and 1 plus x 1 minus x is the quotient, but it belongs to tangent inverse. Okay, but the okay, so if you compare here, so my question is tangent inverse, my w. Okay, so I have my w actually is 1 plus x 1 minus x. It is the combination of the quotient of 1 plus x and 1 minus x. So I need to find dw dx. So how to find? So let the upper part is a u, the lower part is a v. So u equals to 1 plus x. So I have my u prime equals to 1. My v actually is 1 minus x. So my v prime actually is negative 1. So now I have my v square, vu prime minus uv prime. So v as 1 minus x square. V here is 1 minus x. U prime equals to 1 minus 1 plus x multiplied with negative 1. So expand it. You must simplify. This one you must simplify because it is simplifiable. So then 1 plus 1 actually is 2. Okay, and then minus x plus x is 0. So you have a 2, 1 minus x square. Okay, so our dw dx actually dw dx actually is 2 over 1 minus x squared. So now this question will become using the power. So I push down the 2 tangent inverse, copy back what is inside my tangent inverse, differentiate. Following the chain rule, I need to differentiate tangent inverse. So differentiating tangent inverse, it will become following 1 over 1 plus w. What is our w is 1 plus x, 1 minus x, and the whole thing is square. Then multiplied with dw dx is 2, 1 minus x. Okay, now we have a huge problem actually for this term. Because it is 3 layer, so what you need to do, equate the denominator and flip it up, so it will become 2 tangent inverse 1 plus x 1 minus x. So this one will become 1 minus x square, and this one will become 1 minus x square plus 1 plus x square, the whole thing to 1 minus x. Okay, so if you want simplify, okay, this one can cancel off. Okay, this one, if you feel that you want to expand and simplify, go ahead. If not, just leave it as it is. Okay, and please don't go and simplify the one inside the tangent inverse. Let it as it is. Okay, thank you. Actually, that you can try some of the question over here, that is which I'm going to discuss during the class. Thank you.